So I'm still really bad at French, but I'm 5 days into studying in the morning.
I wasn't even aware that you were learning French.
Yeah, it's one of the languages I'd like to learn. I figure I start there because I already had a few years of experience with Spanish in high school.
Mm.
So I wanted a different challenge, and then I figure I'll go back to Spanish afterwards.
Mm. I studied French in high school for a couple years because it was mandatory, learning a language that is, but I don't remember anything from high school. I mean, I don't remember anything about French.
If you had to give a percentage number to what you remember from high school, what do you think it is?
Math and science, I probably remember almost 100%. Everything
Oh
else,
man,
everything close to 0%.
it's a confident number. But I guess if one's 100% and the other one's zero, it makes a little bit of sense. So, what did you forget? I guess is so. What do you think that you could remember now that you've forgotten from high school? That's something I think about. I even looked up a K through 12 curriculum. Have it saved on the computer. I think we should look at it sometime.
Like I can remember most equations, most concepts from math and science, and even if I can't recall them explicitly, if I were to review the material, I would remember very quickly. Um, as for English and French or history, it would be like seeing the material for the first time.
You don't think it would come back quicker? There's nothing going on there. Like,
It's too long ago, and I did not. The information never transferred from my short-term memory to my long-term memory. So I crammed for the tests, got my A's, then just forgot about it.
I mean, even the cramming's like hardly even getting into short term. That's basically just working memory.
Right, right.
um, which, man, we don't need to go down that rabbit hole because we could pull out the over 60 documents we looked over for MemScore, look at those. But
Mhm.
I think just going through that made me understand learning and memory so much more. But also using MemScore, even as little as it has, is made me realize that it's a hammer and it needs a nail. So you have to have a purpose and you have to have a procedure for how you put the information into the tool, and then use the tool to learn the information. So like with Duolingo, I was thinking, taking some of the things I'm learning there and trying to insert it into MemScore or using two tools together. It can be really powerful if used adjacent to something, is what I've been thinking.
Mhm. Yeah, that's an interesting point, and I'd like to have a conversation about learning in general because people only
Hmm.
say that learning or education is essential to lifelong success. I'm sure that they're correct, but still we should dive into the substance of this and really understand why. So when people say learn, what exactly do they mean? Are they just talking about memorizing certain facts? Are they talking about transferring the knowledge to a novel problem? In other words, applying those facts? Is it a combination of both? What do you think?
I think we found out quickly, or I did on a personal note, the memorization is not, it's not the only thing. It's not cognition. Like you have to be able to take those memories, apply it to mental models. They're like fundamental building blocks to those mental models that allow you to apply things in life if you have the capacity. Um, so it's really important, but you can still create a story or create your actions and goals and all the things that we've discussed in the previous episodes without understanding and having it perfectly memorized. But having it either perfectly memorized or memorized to a percentage that suits you is definitely helpful. And if you want to be a master at something, it's necessary. So I'd say a lot of the things that I learned in school, I wouldn't necessarily need MemScore, but if I used it, I would quickly become even, I guess, more of an expert. Um, the things that I could use it for, in terms of general memory use, I think, are like little number games, I guess, or word games, seeing how many words or numbers you can retain. I know we did research on the study, like the 7 plus or minus 2. So we all have like a limit to our capacity of how many numbers we can keep in our head, letters, words, sentences, build on out to even the most advanced like mathematical equations. So it's a way to kind of assess your ability to do that. And some people are just inherently better at that. Like some people are inherently better at moving, but everybody can improve it, just like they can improve their movement. Would you agree with that for the most part?
I'm going to have to qualify quite a bit. Okay, so Reuben said that, like you kept mentioning these articles that we read. I just want to um, explain that a couple years ago, Reuben and I looked at a number of scientific articles, studies, in order to better understand the efficacy of MemScore, which is a program that I developed to improve memory, retention, education, so on. And we saw, we learned about like working memory, short-term memory, long-term memory, how all of those interrelate, and how to improve those. Basically, what's the scientific consensus on these, on memory and learning. Uh, and and yes, as Ruben said, memory is fundamental to application of knowledge. So like consider a computer. A computer has a memory unit, like a storage device, such as RAM or something for long-term storage. And then it has processing circuitry. If a computer only had memory, then it wouldn't be able to execute any program. It would be able to store the program in the memory, but it wouldn't be able to execute it. If the computer only had processing circuitry and no memory, it wouldn't be able to run a program because a program, it doesn't have any program, right? So that's the relationship between the two. They're both indispensable. Together, you can solve any type of problem, just like a computer can solve almost any type of problem. But if you only have one or the other, you can't really do much. So when like this is something I've been told by teachers quite often, they really emphasize like applying concepts and applying knowledge. But if you, for example, don't even remember the math equation, you can't possibly solve a problem that requires that you use the math equation. It's not going to happen. Um, yeah.
Yeah, there's a hierarchy of needs, right? There's a set of tools that you must have in order to accomplish the task. Yeah, learning. Let's say we don't have the tool, right? We're just learning. We have a book, we have pen and paper. What's your best strategy for learning in that case?
Mm-hmm. Okay, so there, I really like to use technology as an analogy for learning because technology was developed to emulate human psychology. So whenever we see the consequences of a certain technological design, we can assume that we sort of operate in the same way. Now, computers have memory problems. Like you can never have enough memory. So like consider the newest PlayStation. I think it might have a memory of 1 terabyte, but a single game might have a size of 100 gigabytes. So once you download 10 games, then your memory's full. You can't download any more games. All right. Now, in order to avoid these types of problems, um, engineers and scientists have developed like methods of data compression. So if you have originally 100 gigabyte file, you might be able to apply some kind of technique to reduce the size to 10 gigabytes. And then you send that file to like another computer, and that computer applies like I guess a data decompression technique, and then it's restored to its original size. So basically, there's a way to condense information and a way to expand information. That is a very useful skill because everything that I've talked about regarding memory and processing apply to the human brain. We have a limited memory, we have a limited working memory, which I guess is more like processing circuitry, your ability to process information. But it's super important that you can condense or abstract various and large amounts of facts into a concept, a rule, and then use that in many situations. That's the most valuable type of information because it allows you to effectively master a wide range of phenomena and without having to use as much memory in your brain.
So with computers, we have input, computation, and output, simply put. And in some ways, human beings are the same way. We're tubes, put stuff in, stuff comes out, there's a computation that happens. Same thing with the information that comes into our minds and how we process it in the ways that we speak and write and interact with other people. All of our senses, right? We're making sense. Computations happen, there's an output, there's a reaction. With computers, we have hardware and software. So if we don't have certain hardware components, we can't run the software. If you lose a significant amount of the computer, you have to throw it away or replace the parts. If I lose all of my limbs, I can still continue operating as a human being and run most of my software. I just can't run this software anymore that was there because of the hardware or the capacity that I had within it. So we are computers in a way, but even more advanced. And some of the things that we're now doing with artificial intelligence, including the protein folding and the modeling, is wild. And I think that in the next 5 to 10 years is going to change a lot about what we know in terms of medicine and where we go and where we've been and what problems we've kind of encountered and what mistakes we've made. That'll be the coolest thing. What have we done wrong? And this thing's going to kind of objectively tell us that so that we can move forward from that.
What do you mean by wrong?
Like in terms of, let's say, treatments or interventions for certain diseases, whether that be medications or different lifestyle changes, was it actually effective? Could you do some sort of study and use within the methods this artificial intelligence to actually improve data collection like significantly? That simply put, that's it. Like interventional studies using this advanced tech to like really see if something is changing in the body. That seems to be where individualized medicine would go.
I don't have much expertise in the field of medicine, but I think I understand the gist of your question. Machine learning can help identify blind spots in our understanding of various technologies, fields, subjects, and so on. I think chess is a pretty decent example. So chess is a very old game. It's been around for thousands, if not more years. And during that time, many people, many civilizations have developed systems for playing the game. Now, those systems have developed naturally that like people have, argued that this methodology is better for these reasons. And the system has just evolved in that sort of iterative process. But with the advent of, I think it's called AlphaZero, which was that's not the first one, but with the advent of machine learning applied to chess, we've seen enormous changes to how chess is played. These computers are able to use their enormous processing power and their sophisticated algorithm to experiment and play just magnitudes more games than any individual human could. A human might be able to play like 10,000 games in a lifetime, but a computer does that maybe in an hour, maybe even shorter than that. And AlphaZero can play hundreds of thousands, millions of games within a year. And it learns so much with each game, and it invents new strategies, new tactics, new everything. It can't communicate to us its knowledge. It doesn't speak English or any other human language. It only communicates using bytecode, like ones and zeros. But it, if a human researches those games that AlphaZero plays, then the human can extract or infer certain ideas. Like, oh, he recognizes these patterns and how AlphaZero is playing. Is like, well, this is contradicting a fundamental presupposition of how humans play. But when the machine does it, it dominates. It just beats the human strategy. So what you've been seeing in chess and in a lot of these kinds of games, um, like wherever machine learning is applied, is that humans will imitate the machine. Like once it's clear that the machine is doing better in these fields, or in these applications or areas, the human will just take all of those ideas, those concepts, and apply them to themselves, and they'll forget the past because they know that it's not superior anymore.
Most definitely. And just to for the audience, it's AlphaFold is the specific name of the protein modeling that DeepMind was able to create. And I'm looking at an article from January 15th. They were published in Nature, which is, as you know, like one of the most reputable journals that exists. And yeah, 50-year problem of trying to create these 3D models. So there was a huge data set of information from just studying the genome. And then over time, they were able to make something that works. And they right away say what I was saying. It's like, it's just going to change research. It's going to dramatically improve how accurate we are with, certain scientific statements, I guess. Mm-hmm. So back to more specifically with learning and how human beings learn in a similar way to machines. How do we construct our own like mental models similar to AlphaFold, right? In DeepMind, like what if you had to go from 0 to infinity or 0 to 100? What is like most important? How do we get there, man?
Yeah, it's two terms. First, the error function, and then the objective function. It might actually be called the loss, error or loss. Here's the process for how a machine learns. Most machine learning algorithms, they have some kind of equation that defines what the ideal goal is. It could be the value of a house. So the objective of this machine learning algorithm is to determine the value of a house based on some data set provided to the machine. Okay. Now, the machine is going to form a hypothesis. They don't call it that in the computer science realm, but they're effectively forming a hypothesis. They're going to say, well, for this house, I'm guessing it's worth $1, right? Then they're going to test their hypothesis by comparing it to the ground truth, the actually correct number. And then they're going to determine the difference. That's called the loss or the error. And they're going to try to reduce the amount of error iteratively. So a computer, like you said, looks at the receives some input, processes it. It's like kind of like in a black box. You don't really care what's happening, but it just processes it, and then it produces some kind of output. Well, here the input might be something like, what's the square footage of the house? How old is the house? Where is it located? It'll look at all these factors, and what makes a machine more appropriate for this task than a human is that a machine can consider tens, if not hundreds, of variables at once. Humans can only maybe think of 5 to 7 because of their limited working memory. But anyways, that's why they're really well suited for processing this input data, and then they'll spit out some output data, which is the value of the house, and then they're going to just reduce that error progressively until astonishingly close to the ground truth, and then they just predict based on new input data.
Um, if you're finished with your statement, I think there's a very good video posted by Lex Friedman that shows him playing guitar, drinking water, all while the self-driving car or the autonomous vehicle is moving forward and sensing um, the environment so that it can drive. And when it's viewing internally, right, it is guessing or forming that hypothesis. And when he is playing guitar, it's close to 100%, but it's never 100%. It's like 99.1 to 99.9, and it just fluctuates, right? And then when he drinks water, it's the same thing. So they are never like 100% sure, but they're as close to it as possible. I think that's very cool to learn from AI. What else can we learn from AI?
Mhm. Yeah, it's a computer is not afraid to fail. So
Mm-hmm.
that's what an error is. An error or a loss is a failure. The objective function is the definition of the goal. Like we're supposed to, or the machine is supposed to produce something with zero error. But if you look at its progress, it actually starts almost always with an enormous amount of error. In the example of the house, a machine might actually guess that a house is worth $1. That is within the realm of possibility for a machine learning algorithm because it doesn't really know. It is starting from scratch, but it's not afraid to fail. Machines don't have emotions the same way that people do. Um, and it will fail not once, not twice, but actually tens of thousands, hundreds of thousands, millions of times. But what distinguishes this computer from people is that it will learn from every single failure. We can measure the loss, and you will see that with every single iteration, the trend is that the amount of error decreases. So if initially it was, 10 on some arbitrary scale, if the error was 10, then after 1,000 cycles, it might be 5. After 10,000 cycles, it might be 2. After 100,000 cycles, it might just be 1 or less than 1. And then that might already be much better than any human could do. It's this it's this iterative failure with the sub goal of reducing failure that makes the machine such an effective learner. And if we can apply that to ourselves, then we also will have the capacity to uh, oh, do things that other people can't. Just do extraordinary and impressive and wonderful things.
Well put, man. Like Lex talks about how a lot of machine learning is beautiful in his eyes, like because it just makes so much sense, and there's things that we can take away from AI, almost like it's teaching us from its point of view. And obviously, it takes a mind ready to think those thoughts and to believe that. But what is truth to a computer, to an AI?
It's whatever you call truth. Like there's a task called labeling. So a human will label some kind of object um, as true. They'll literally call it true or they'll call it false. So maybe it's an image of a intersection with certain traffic signs and other objects. And a human will literally draw a square over a traffic sign and label it traffic sign, and then maybe even true. Or they'll draw a box over a person and say person, or like they will label this, and the machine will process that, consider it as true. And then if the computer is starting to make a prediction, so you give the computer a new image without any boxes, without any labels, the computer will like predict whether this is a person, whether this is a traffic sign, whether this is whatever, and then it'll compare it to the labeled data, and then it'll start calculating differences. There's something called supervised learning. So a human might also intervene during this process and just say like, no, computer, you predicted that this is a person. It's actually a traffic sign. And then that input from the human will also be considered a ground truth.
And we are, for example, with if you're on a Google Chrome website, you may have to enter in or select like all the stoplights. We are teaching Google's AI in some way. And then if we get it wrong, if it thinks we are wrong, I believe it sends us another one. So it's kind of checking our work almost. If you just put in random selections, it'll say, no, that wasn't correct. So we're slowly but surely making it more intelligent. And it does that with all of our data with it, which is another big discussion. We would need Andrew Yang for that one.
Yeah, about the implications of automation on the economy.
Mm-hmm. And he's also big into like so the data dividend and trying to get people money or for the data that has been taken from them, whether they knew it or not.
Yeah.
He's out there. He's out there doing things.
Mm-hmm.
So you establish kind of what truth is to a computer and the fact that they are willing to accept failure. Well, I mean, I'm anthropomorphizing. That's just built into them. Failure is part of their strategy to find success. And it's wild because there aren't really consequences for that process with the AI, right? At least I don't think. But if we did that, if we made 1 million failures in a short period of time like they do, we may not be around. So like some of ours have more consequences, even though there are things about us in our computer, our hardware, our software that's more advanced, I guess, or superior. They have some parts that are far superior than us.
Mm-hmm. Like we do have an advantage over machines, which is our intuition. We don't require as many examples to learn something or infer something. A computer might require 100,000 cycles to figure out to move a pawn from this position to that position, but a human might be able to figure that out in just 5 games. Or a human might be told something abstract, like a general rule or a general theory about pawn structure. I'm talking about chess here, if it's not clear.
Yeah.
Yeah.
You're not talking about ponds like lakes.
Oh, no. Um, so a human can just learn some general rule or general theory and then apply that to play the game correctly, so to speak. So we have, just to reiterate, we have really good intuition, and we also have a much better ability to interpret information. A computer can only understand ones and zeros, but we can understand any variety of languages. We can, like, English or French or Chinese or even math. Like, math is, those are just strings of characters with weird shapes. But we're able to produce some of the most complex and intelligent work with that. Um, yeah, so we should remember that we have these very positive qualities, and then we should try to imitate the machines where they outshine us, which is likely their openness to just experiment, their willingness to fail, because they don't understand this, but by doing that, they're able to find success. We, on the other hand, are so often wrecked with, like, with this sense of inferiority, with this sense of embarrassment, with this sense of shame, that we almost prohibit ourselves from testing our limits, and that's when we stunt our growth. If we are open to learning the same way a computer is designed to test and fail, I really think that our potential is impossible to measure.
Here's my final question. If human beings, have made these machines, let's say in the simplest form, to be servants to us, we enter the function and it does it, right? We tell it what to do.
Mm-hmm.
How can we better serve our own learning, right? Like if this is the mainframe or the motherboard of the computer, how can we as human beings in our person serve that thing?
Yes. In the past, our main goal or problem has been figuring out how to do things. And now machines are becoming better than us at figuring out how to do things. That doesn't mean that we become irrelevant. That means that we start to focus on different parts of the design process or the problem solving process. Like, for example, we're going to start focusing more on sensing. Like, what exactly do we need? What do humans need? What exactly do humans want? A machine, even a sophisticated machine learning algorithm, probably can't figure that out. Like this collective desires of 7 billion, 8 billion people. No, that can only people can very efficiently and directly do this. So, so a computer can't predict that. Like we want something like Instagram, but a human clearly did.
Mhm.
All right. So people will be able to focus more on idea generation, and then they will use the machine with, uh, I guess, idea facilitation, just implementing the idea, and then humans will also still be able to provide valuable information in terms of defining the like intended outcome of the machine learning algorithm. It's like no, we don't want the machine to, you know, to relate it. It's like providing ground truths. We still need humans to provide ground truths to the machine to better tailor the machine. We shouldn't think of machines or artificial intelligence as making us unnecessary. If anything, it augments our power. It's a tool that we can use to achieve our dreams. And the barrier to entry is lower than ever because all you really need or all you will need in the future is an idea, and then you'll have a very powerful machine learning algorithm to execute it for you.
Yeah, I posted on my story what the AI said about our podcast, and it's very it's good in some parts and then not very good in other parts. So it has some learning to do. But even if you took that and then, like an English or grammar professor, went over it and changed some things, that's a pretty good way to start, right? If you have writer's block, you have no idea where to start, let the AI start it for you, and then you edit and take it from there.
Mhm.
And then you could probably just keep recycling that piece into it, and then you and the machine very quickly spit out something that is yours, but you had a really good assistant. And how is that any different than using a dictionary or using Google or a thesaurus or using references from other people, right? This person now is just your AI friend that is learning with you, and your job is to now teach it to be better. There's a really cool application developed by some people at WashU called GritX, and there's an AI called Darwin. They may be changing their name, but you teach it how to talk to you anytime you need talk therapy, right? So let's say you're like, "Hey, I'm sad today, Darwin." It'll kind of motivationally interview you into a place where you can now go out and have a little bit better of a day, maybe even down to learning your favorite books and movies and stuff like that. Hey, did you see this was out? Maybe you go check this out at the movie theater. It's like having a little friend that is not actually a person. So that's already here, and you can download it. And then imagine where that's going to go. When our job now is to sense the environment, kind of be like the tentacles for the AI, and tell AI, hey, this is how you need to run, because we are the people sensing. We are the people in control telling you what to do.
I think this has been a very good conversation, Ruben.
Me too.